Perfect.
Much betterer.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 130. Today we're talking about an upside-down 3D printer, a biplane quadcopter, gutting a calculator watch, and GitHub CoPilot. Did you hear about the tools, Elliot?
I read about the tools.
I also read about the tools, and I'm kind of, I don't know what's going on here. So the story that's coming out is that Home Depot has been testing out a way to activate certain high-end power tools at the point of sale. So like if you were to steal a high-end tool and take it home, it wouldn't go because it hadn't been activated. And they're actually saying that this is to thwart organized shoplifting, I guess, organized crime that is stealing, high-end tools in mass and I guess reselling them out the other side. But I think for us, the more interesting thing is, how are they doing the activation?
Yeah, and how do they think that organized crime isn't going to figure out how they're doing the activation and then just copy that? Like, what worries me about that explanation is that this is going to stop the not very motivated or not very tech savvy thieves, but the ones who are doing it at scale, they're just going to have somebody make the device that reactivates it for them and problem solved.
Well, that's an interesting thought. I don't think it's going to stop the not very tech savvy thieves because they're not going to know that the tool's not activated. I guess they'll put big stickers on it or something like requires activation.
The not very tech savvy thieves are going to have to come to me and pay me my cut to activate their tools for them.
Yeah, Elliot
Kingpin.
big into criminal activities.
Kingpin.
Yeah, there you go. So I thought when we talked about this in a pitch meeting, I thought your take on it was very interesting in that these tools have electronic speed controllers by and large inside of them. It's not just like a potentiometer on the trigger anymore. Like you actually have an electronic speed controller. And so it wouldn't take much to build in a flag inside of a microcontroller that would activate the ability for the tool to work. The challenge is then how do you get power to that controller because you would have to somehow interface through the box without taking it out in order to turn that on. Because if you think about it, it can't be a technical solution. They want to implement this in every one of their stores eventually. And so it has to be the kind of no friction thing where the clerk runs it through the scanner, and as part of it running through the scanner, it activates the tool in the same way that those anti-theft tags that set off the alarm by the entry to the store get deprogrammed at the point of sale.
Yeah, so the thing has to be energized when it goes out the door, right? Assume it's Bluetooth or NFC or something like that. And they have to wave this wand over it that then talks to it. But it has to have a charged and working battery in there. And it has to be sitting there listening for this, token that it's going to get. I still don't fully understand it. I also don't understand how people are walking out with, large power tools without them being noticed. So there may be a lot about this thievery that I don't fully get.
Now, that's also interesting when you mention NFC because there are a lot of NFC tags that don't have power on them and the reader gives them power. So I could actually see if you build an NFC reader into the active hardware of the tool, and then you put a tag on the inside of the tool case, then you could write a data value to that tag that then every time the battery is put in to the tool, it reads the tag to see if the magic key is there.
This whole thing sounds slightly implausible to me. I mean, I guess I'm wondering if it's going to be it fails after a few years if you're stuck with a bricked tool, or if it's, going to be locked to the owner so it prevents resale of used power tools or something. This seems like such a large solution to, a more easily solvable problem that it makes me wonder if there aren't ulterior motives.
Oh, so you're saying that they're putting this in place so that they can do tools as a service in the future?
That's my Black Mirror version of this story.
Yeah, I think that's less plausible, though. I mean, really, going to this whole theatric level of putting this out there so that they can then later, it's the Trojan horse for subscribing to use your own tools. I don't know about that. I think it's probably some anti-theft idea. And I think someone in the comments said, there's no way this is going to be widely implemented. It's probably some campaign to get the word out there that you shouldn't steal tools from Home Depot.
oh, maybe it's all a smoke screen. Maybe
Right.
they're just going to be like, beware the cyber tools. And then you're not going to steal tools anymore. Oh, that's
Maybe,
good.
yeah. I don't know. I don't know the ins and outs of organized tool theft.
Yeah, I don't
Like,
either. And the crime aspect of this is like totally out of my wheelhouse. I'll give you that.
well, let's leave that one for now. Obviously, if you are able to get your hands on one of these tools and tear it down, we want to hear about it. So tips@hackaday.com. But until we see that, the next thing we should talk about is my phone repair, Elliot.
What's that?
So I pulled my phone out of my pocket one day. It's a Pixel 3.
Yeah.
And the back case of it had bulged out.
Ooh.
And I was looking and I'm like, oh, this is lithium battery, right?
Ooh.
Lithium battery is pushing the back of the case off. So
Double creepy.
yeah, I ended up ordering a repair kit because I looked at let's say it's involved to do a battery swap on this phone. And so I ordered the repair kit because it came with all the tools that you needed, including like a sausage size, like a 10-inch long sausage sized packet filled with goo. And you put it in your microwave for 30 seconds.
Right.
And then you lay it on the back of the phone because the phone case is glued shut.
To warm it up, to melt the glue.
Yeah. So luckily,
God.
because it was bulging, it was not difficult to get under the edge of the case on this phone. But that glue is strong. So it took me a while to get the thing off. I got the screws out okay. There's like a tape shield that spans like the top of the motherboard onto the top of the battery to shield it from the inductive charging coil for the wireless charging. So you got to like peel that back off of the battery, which was very puffy when I got into it.
Yikes.
Do you know those, like, I know them by the brand name, the 3M command strips, which are like adhesive that you stick to the wall and then you can take it off by like pulling laterally and it stretches that adhesive out?
Yeah, it's one of those like gummy adhesives. Those are awesome.
So they use that to glue the battery in place. And only 2 of the 3 of those broke. So I got 1.5 of them out. And then got the thing off. But the most awful part of the repair was cleaning the goo off. I spent hour and a half trying to clean the goo off the back of the case and the frame of the phone. And I got to tell you, there's a big difference between 70% isopropyl alcohol and 91% IPO.
True that.
It's like water versus acid.
Yeah.
So once I ran out and got the stronger alcohol after the first half hour of trying, the next hour of cleaning that stuff off was good. And then to glue the whole thing back together, the kit came with a perfectly cut piece of like 2-sided adhesive material that I managed to get pretty much aligned and got the phone back together. But I will say, when we talk about right to repair, like I get it. Like this phone is very sleek and very slim, and that's what I want. And if you tried to put like clips or screws or something to put the back of the case on, it wouldn't have been like that. And like gluing it shut gives it its water, it's, I don't know, IP65 or some rating like that. I'm not sure which one it is.
Sure.
But God, the phone still works wonderfully. It's still super fast. I still really like it. And the battery was, you can get a battery for like $10 or something. I think this whole kit was like 50 and whatever. It's worth it. Boy, to just ditch this phone because it needs a new battery is wrong.
You know what? I changed the battery 2 years ago on my Samsung S4. You know how I did it?
You slipped the back case off?
Yeah, I just clipped the back off and I put the new battery in.
Yeah.
It's also how I changed SIM cards.
Yeah, there's a SIM card window on this one. So, that upsets me a little bit. But now check this out. The real sour part of this repair, this phone is only guaranteed to get security updates through November of this year.
Oh, man.
I know. Doesn't that suck? 3-year-old phone. Yeah, well, I was going to say everyone should tune in December when I discuss what it's like to put a custom operating system onto a Pixel 3.
I was going to say, your phone's new enough that it's going to be super well supported by
I think
Lineage
it will.
or whatever. You'll be fine.
Yeah, because my opinion is that those security updates are important.
Yes, I believe that they are.
This is a journey into sound. What's that sound?
What's that sound?
Now it's time for What's That Sound? Last week I played for you all a sample from a super early, maybe one of the earliest vocal synthesizers. This is the Voder. It was more like a scavenger hunt than a who knows this sound from what it sounds like. And 26 of you bid on it and got the right answer. So good job to everyone involved. I wanted to include it because I think it's so awesome. This is a speech synthesizer from before the era of computers. And so the thing was played by a person. In fact, they had a trained group of like 12 women who trained for a year to be able to play this thing. It has keys like a piano, except there's 5 of them under the fingers, and there's foot pedals that control the pitch.
Who saw you?
She saw me.
Whom did she say?
She saw me.
Well, did she see you or hear you?
She saw me.
Instead of driving the different sounds by electrical signals, you're driving it here by pressing a bunch of keys in. It's a fantastic demonstration of kind of how we knew so much about how sound was made back then, but we didn't have the techniques that we do today to like recreate it. I just thought it was a charming early voice synthesizer, and I'm glad everybody went and looked it up. That then brings us to the random drawing. We got 26 people. I am doing this in R for no good reason. Random uniform times 26. The answer is, drumroll please, number 23, which is Michael Kolozowski. Congratulations. So congratulations, Michael will get a t-shirt sent straight out to you. And the winner of the best nickname this week has to be Norbert Wiener Dog. And extra special thanks to Anonymous for sending us the link. I'll throw the link in the show notes. It turns out we had covered the voter way back in 2014. So go ahead and read up on Hackaday's coverage of it if you haven't seen that already. It's actually a really great write-up.
Christina from way back in 2014. That must have been one of our earliest articles.
All right, should we start up some hacks?
Let's do some hacks.
Okay, my first hack this week is from Benedict Befinitive. This is Raspberry Pi crammed into old film camera. I love this one. In fact, I love it so much. It turns out we ran this one a couple weeks ago.
Oh, no.
And this one's a dupe, but we didn't talk about it on the show, so here I go. This is really cute. It takes an old film camera and uses the space where the film would go and where that little film cassette spool cartridge thing would be to cram a bunch of electronics in there and convert it completely non-destructively and totally temporarily into a digital camera. And it does this with a Raspberry Pi Zero W so that you have wireless and the little camera from that. And he pops the lens off the camera so it's just the sensor. He's got a really nice 3D printed piece that kind of mimics the old cartridge and film plane there that then fits the Raspberry Pi W in there. There's a space for a LiPo and a battery management circuit and I guess a step-up converter inside where the film used to sit. And then you just close the camera up like you would back in the old days and you can take pictures. I saw this. It's a simple hack to replicate. To me, it's just totally unbelievable that you can fit all of that inside where the film would normally go in an old camera.
Yeah, I was surprised that the Pi itself with the components on wasn't too thick.
If you have one of those old cameras, they usually have a spring plate on the back that would hold the film dead flat against the focal plane where it's supposed to be. And so, you know, it might be springing a little bit. Like, this isn't exactly a high resolution hack. The image sensor on the Raspberry Pi camera is really small, and that means you're getting kind of like a telephoto lens effect out of it. So if you want to focus on something way far away, it's actually really good for that.
Yeah, but if you think about it, it's sitting where the frame of the film would have been. And so you need a sensor that's the size of one of those film frames. So this is like, I don't know, a tenth of the size or something.
Yeah, so you really want like a 1-inch sensor, and this thing is like a, I don't know, a 1/4-inch sensor or something. So it's only getting a tiny little fraction of the total image, but it's digitizing it with really pretty good resolution. So if you've got a good lens up front, it's actually going to be a fairly capable camera, which is fun. The other things he doesn't talk about in this are that you have to figure out a way to hold the lens of the camera open, but a lot of these old cameras have a bulb mode for long exposures. But then the question came to me, how do you take a picture with this? And the answer is he's not. He's using it basically like a webcam. And then I was like, oh, that's a cool idea. I wonder what he's using. And I'm like, oh, this is Befinitive. He's the guy who wrote Wi-Fi Broadcast. So this is a super duper extra cool hack because he's using my favorite hacked up Wi-Fi video over Wi-Fi protocol, which is Wi-Fi broadcast. And I guess I wrote this up way back in 2015, so you should check that out. Wi-Fi broadcast is actually still totally relevant today. It's being used in a bunch of like long distance drone autonomous vehicle control systems to send the video back. So it's really cool. It basically just, instead of sending the video like you would over Wi-Fi using TCP/IP, it just sends the video frames raw as UDP and it just spits them out. I guess it makes the delivery of each image a little bit less reliable, but it makes it faster, it reduces the latency, and it makes it kind of more like a broadcast. You should absolutely go check it out. I'll throw links in the show notes.
I came across this next hack over on Hackaday.io shortly after Dave Darko had published it, and it is truly after my own heart. It is a calculator watch, and the project is to replace the circuit board inside of it with one of your own choosing. The thing that I love so much about this is you could just go on AliExpress and buy one of these watches for $3.50, and they say they've got about 70,000 of them available to sell. So you don't have to worry too much that you're not going to be able to get another one at the other end of the project. For me, I think the reverse engineering part of the screen on this one is well worth the read. So Dave talks about sanding off the solder mask on top of 22 vias and then doing some point-to-point soldering onto some prototyping board that you can then put into a breadboard and access a little more easily. And he goes into detail with an oscilloscope about how these segments are being driven. And so you have common pins, and then you have pins that are the segment drivers. And you have to figure out whether the segment wants to get 3 volts or negative 3 volts. And so you would change whether you're putting a ground potential or a voltage potential on the common pin in order to get that positive or negative voltage. Basically switching which pin is 0, which pin is 3 volts.
What's Dave going to do with this thing? What's his long-term plan?
Yeah, I don't know about that either. I mean, there's not a lot here. It's an 8-digit 7-segment display. There's a colon. There's some words along the top like month, date, AM, PM. There's 20 buttons on the front of it. And so he already has some KiCad footprints for how to do those buttons. You know, it's kind of like the 2 combs of copper that are interlaced, and then the button has a conductor that bridges those gaps. So like that's all figured out, but I don't know. I don't know what it's going to look like. I did ask him in the project page what his plan is for power, because I always look at these things and I'm like, that's where the difficult project problem is. You know, it's using a SAM L22. I'm not familiar with that particular chip line. I'm assuming it's low power. But the thing that definitely came to mind when thinking about this power is the Good Watch from Travis Goodspeed. And that one, I think he gave a talk on the low power techniques that were used in it. But it's, you know, it's a pretty mature project. So you can go and actually look in the code and see what was done there for power down modes for a wristwatch.
All right, my next hack is the coolest 3D printer hack of the week. This is from Crawlin. Strangest upside down 3D printer fits in a filament box. This is the story of the positron, and this is a 3D printer that primarily on its face is astounding because it prints upside down. And if you haven't been following 3D printers, you might think you need gravity to run a 3D printer. But it turns out, I mean, they've printed in space. It's actually an old party trick to like pick one up and hold it upside down. And if your frame's strong enough, nothing really bad happens. In this case, he's designing the thing from the ground up, upside down, and he gets a lot of extra mileage out of it. And it's just chock full of interesting design features. To make a long story short, if you design a 3D printer upside down, you get to put the heavy stuff, the motors that move the print head around, the print head itself, on a nice solid base. This one drives both the X and the Y axis on kind of an H-bot, And all of this, the motors, the extruder, is attached very firmly to a solid platform base where it won't shake so much. Instead of, if you think of a regular 3D printer, you have all of the heavy stuff at the top and it's like moving back and forth and trying to shake this thing around. Here he's got it the other way around. The heavy moving stuff is on the bottom. It's a much more stable machine. He does some other clever things like using these synchro mesh cables. I'll throw a link in the show notes. You have to check those out. It's a steel cable with a solid kind of helix that goes around it. And so instead of using a timing belt or a chain or anything like that, use these funny cables. The advantage here is that they can turn. The blingiest design bit here, I think, is using a transparent build plate. And to do that, he just uses a piece of glass and he tapes copper like window heater tape down on it and uses that. Why do you want a transparent build plate? Well, because if it's solid, you can't see your print being printed because it's upside down and it's blocking you. It's just so much cooler if you can see through and watch it all go. And kudos for that.
I thought it was interesting to see the part about doing bridges without support on them, because since the nozzle is pointed up and you're squeezing plastic up, when you come back, anything that's drooping is kind of going to get pushed up by the nozzle again. And in this case, he's talking about, was he talking about like 50 millimeter bridges
easy.
And having them coming out pretty nice, which I thought was cool. You know, that whole thing about, you know, rotating the build plate 45 degrees off of the base because it lets your motors move further towards the edges of the build plate. Like, there's just a lot of cool stuff in, you know, the design that he highlights in the video, which really makes it worth watching.
The last cool thing he did, he wanted to make this ultra small and kind of easily backpackable, and its footprint is really small, but it has to also be short so that it fits nicely in your bag. And to do that, he actually designed his own special hot end, because if you think about it, it's printing upward and it needs to be riding on this XY thing. The thinner you can make it, the better. And so his hot end actually has a 90-degree bend in it. So the filament comes in from the side and then makes a turn up before it gets heated. Kudos for taking the design goals extremely seriously. If you want to see where parts of this design came from, you should absolutely check out Jeff Kerr, who goes by Lobo CNC's work. He had also done one of these T-Bot kind of upside down 3D printers, but this one from Krallen is easily the most sophisticated, finished, and absolutely, frankly, marvelous 3D printer I've seen in a while.
I've got a drone the next on the list. It's a vertical takeoff and landing tail sitter that Danny Conradi wrote up by Peter Rysek. The interesting thing about this is that it immediately looks like a four-rotor quadcopter, but you'll notice that the rails on either side of it are wing-shaped. So the point to this one is those rails, which also integrate the legs for the thing to take off, immediately become biplane wings when it's turned on its side. And so the goal here is to have a lot more efficient, as far as energy is concerned, flight, because as soon as you get to an adequate elevation, you can turn the thing on its side and rely on the lift of the wings to keep it aloft, and then just need to pull it forward through the air with the rotors, which takes a lot less energy than it does to support the entire weight of the thing with those blades.
It's worth noting that Peter is at UMD, Maryland, and this is a project he's been working on for a while, and he's written not one, but two papers about the mechanics and the control of this thing, because it's actually a really hard problem to go from pointing upwards like you're a quadcopter, you know, transitioning from this mode where you're being held up by the helicopter blades to one where you're being propelled by the helicopter blades and held up by the lift of the wings. And he's done a lot of work on that. You can read about that in his paper.
So there's an up and a down to the wings, right?
Yep.
Like you can't go left when you're supposed to go right from vertical, because then the thrust will push your vehicle into the ground.
Right, exactly. And that's because the wings need to be kind of stable, right? Like you don't want the plane to like rock back and forth. You want it to be stable and in the air.
In the video, there's a bigger version of this that is the University of Maryland research footage, and that one is receiving funding from DARPA for the development, and they're looking at carrying a payload. So you would put a payload in the middle between these two biplane wings, and then you get a longer range from point A to B when it's flying with the control of those wings. An interesting thing that someone pointed out in the comments of this one is that crosswind becomes a problem during takeoff because you have this wing. It's like a big sail. And so I do think this is primarily a biplane and secondarily a quadcopter.
Oh, right. Yeah, you don't want it to get like pushed over when it's taking off.
If you look at fixed wing aircraft that are vertical takeoff and landing, the issue is always how do you turn the thrust to point toward the ground? And there might be a cowl that turns and redirects it, or the entire engine, motor, however you're powering it might turn. But in this case, nothing turned. The whole aircraft turns. Like there's no swiveling mechanism on this, and I think that is the interesting part of it.
And what's up from me next? Yet another 3D printer. This one is Thomas Sandlander's video, 3D printer automated bed swapping system loads from a magazine. This is motivated by Thomas's fancy YouTuber problems. He's got this really awesome new printer, and it prints so fast that he gets prints that used to take like 6 hours or 8 hours done in like an hour and a half or 2 hours. And that means he has to always be going back to the printer and reloading it, taking the finished part off, reloading it. And apparently, when you have the fanciest, coolest printer that prints so fast you can't keep feeding it often enough, that drags you down. So what do? You build yourself an automatic bed swapping mechanism. And this thing is a beautiful piece of machinery. He doesn't talk too much about it in the video, but there's a fantastic build montage that kind of visually explains everything. And all the parts are 3D printed or kind of standard parts that you would use in a 3D printer. In fact, a lot of them are scrapped out of old 3D printers that he has. Again, fancy YouTuber problems. He has like miles and miles of 2020 extrusion from like 3D printers that various Chinese firms have sent him to review. And he's like, well, I'll just take those apart, screw them together, build something new out. The device itself is basically a second heated bed made out of aluminum with a magnetic plate on it. This then holds down a series of little bed platforms that get placed on it, and then it drops down so that they're free, and then it kicks it out and it puts the next one on. So think of like what is this like?
So it's like the trays at the cafeteria when you take them to be washed, you put them on a track and one tray pushes the next tray pushes the next tray. And if the washing machine itself was automated, what it would do is it would lift that tray up vertically, do the washing, and then put it back down. And then as you push more trays in, the clean ones that would get pushed out. In this case, it's 3D printed frames that have these magnetic or have these metal flexi spring steel build plates on them.
The thing that looks like the hardest design challenge here was getting the plates to come loose, because these magnetic build plates actually stick on really hard, and to get them off with your hands, you can kind of pry up from the edge, but it's hard to get a machine to pry. And so he just kind of brute forces it. This thing pulls down so hard that even against the full force of this magnetic bed, it's able to pop it loose. And it does this by using a combination of a worm gear and kind of an interesting slanted mechanism that pulls it down. He loses like most of the Z height on his printer when he puts this on the fixed bed of his otherwise quite hefty printer. I think in the long run, if you were serious about this, you would build the 3D printer around the like bed changing device. But for a first draft, this thing looks super.
VG encountered the problem that his Sennheiser microphone just would not connect to the receiver that he had. And he started looking around and realized that they do come on different channels, and this one was not set up to talk to that channel. It appeared, though, to be a software problem because someone on eBay was offering the service of reprogramming these so that they would connect properly. for the low, low price of 119 euros, Elliot.
Yikes.
So, like any good hacker, VG figured, if someone else is doing this, I must be able to figure out how to do it as well. And kind of went down the rabbit hole of figuring out how to rewrite the frequency commands that are being used on this. It's a wonderful read. It's about, I'd say, 5 parts on his blog. And it really comes from a point of someone who is very comfortable reverse engineering software, but maybe hasn't done a ton of hardware before, yet finds his way through it really, really well. There's a PIC microcontroller that is talking over I2C to a frequency chip. He calls it a PLL. I'm sure there's a PLL in it, but I think it's got a different name. It's a PMB2307R frequency synthesizer. And so part of the problem on this is figuring out what the commands are doing. There's an EEPROM that's storing a lot of what's being sent, and he immediately sniffs that and looks for, something that looks like it's going to tell him what frequency the microphone is operating on it. But it turns out that it's really what's going to be shown on the screen, and the commands that are running this are actually much more intricate.
So does he have to reprogram the PIC in the end?
That's a good question. I'm a little fuzzy on whether he's reprogramming the PIC or reprogramming what's in the EEPROM. Yeah, there's a big spreadsheet that he uses to kind of bring all these puzzle pieces together. And I think it's a pretty good example of how to be organized in a process like this, because you'll see him going back and forth between what he's sniffed on the I2C bus and then what he's reading in the data sheets for these different parts. And a big part of that is that there's a serial control protocol for the frequency synthesizer chip, and the PIC isn't really keeping things in that same order until it sends the packets over. So it really is like bit for bit figuring out what is the PIC doing for this frequency, what does it need to be doing differently to get on the frequency that I want it at. But the good news is you got it working.
My quick hacks this week are 2 tips that you probably need in your toolbox and one that you probably don't. Starting up first, a tool generates interactive PCB diagrams from KiCad. This is a continuation of a project called Pinion by Jan Mrazek, which generates a nice HTML version of a PCB you've made and then tells you what all the pins do and what all the buttons do. It does this automatically from the KiCad files, and the end result is a web page where you can just mouse over all of the exposed pins and they're labeled for you. It's a beautiful piece of documentation. Next up, Eric, a dedicated LED animation framework for ESP32, because let's face it, you've got all that power. It's got 2 processors, it's got Wi-Fi. What do you want to use the ESP32 for? Blinking lots of colored lights. This one makes it easy for you. It actually provides a web-hosted LED blinking IDE, self-hosted on the ESP32, and a programming interface for Windows. This will help you make fancy animations on WS2812 LEDs simply and easily. And last up, this is the tool that you might need. This is 3D printed tooling enables DIY electrochemical machining, and I had never seen this done before. It's basically electro etching, except done to kind of dig deeper into the surface of a piece of metal. In this case, Amos has taken Suzanne, the famous blender monkey, 3D printed it, copper plated it, and then as he moves this electrode that's shaped like the 3D object he wants to emboss closer and closer to a piece of stainless steel, he's flowing electrolyte through there, and it's slowly but surely eroding the stainless until the monkey's face is embossed straight into stainless steel.
First up on my list is one that I wrote called This is a 3D Inkjet Printer. It's a piece of technology that I spotted in an old episode of How It's Made, obviously the best show ever. And it's a company that makes terrain maps, 3D terrain maps. So think of something you would see at like a national park or a ski resort. It's easy enough to figure out that they use a milling machine to mill these contours, but then how do they get the full color terrain prints on there? And they have a custom inkjet printer that has each of 4 different colors on its own z-axis traverses over it just above the surface, spraying ink as it goes. Next up, Charger Caddy shows what 3D printers were meant for. This is a really quick example of being clever. If you have cables all over your desk and you have cable pass-through grommets in your desk, this goes in the grommet and it will have clips underneath the desk that each of your different charging cable for your laptop and your phone, your tablet, and whatever else hanging right there. But when you pull the grommet up, it also pulls the ends of those charging cables up so you can lift them up and use them one at a time. Finally, I have Ostrich Robot Machine learns itself to 5K. This is a robot that looks like ostrich legs that taught itself to run and successfully ran a 5K. The machine learning part of this is interesting because it's a holistic process. Instead of teaching each joint individually what it might be able to do, they put the whole robot together and then gave it spatial goals to figure out how it could stand, balance, and run. But if you start reading into this, it becomes even more interesting because they're using the same platform to work on proprioceptive feedback for blind stairs traversal. What that means is there are no cameras or other visual input. The robot is learning how to balance and navigate the environment just by knowing where the different parts of its legs are. And so they're teaching it to walk up the steps without actually seeing the steps. It's time for our can't miss articles of the week. This is long form content written by excellent Hackaday writers. What did you pick this week, Elliot?
I'd like to start off with Lewin Day's write-up of Murata's plan to deliver solid-state batteries to market in the fall. Solid-state lithium batteries are fantastic. It's got all of the in principle. They don't really exist yet. It's got all the power density of a lithium ion or lithium polymer battery. They're rechargeable batteries. Instead of using a polymer or liquid electrolytes in the middle of the battery, this one aims to use a ceramic or something solid to form the membrane that lets the battery charge and discharge as the lithium ions cross the barrier. What's cool about this? Well, on the one hand, at some super big scale, these hold promise to be rechargeable batteries that can recharge incredibly quickly and probably won't wear out nearly as quickly as the standard lithium batteries we have now. So, this is kind of the 10-year away goal of a phenomenal battery-driven car future. And in fact, Lewin has written up an article on this about BMW's plans to have solid-state batteries in cars in like 5 years. But this is even closer, but on a totally different scale. This is by this fall, Murata, which makes, for instance, multi-layer ceramic capacitors, will be putting these batteries together and selling them to you. And they have extraordinarily low capacity, but they're also kind of the size of a 1206 component. And because they're going to be solid state, you can solder them onto a PCB, or even more tantalizingly, they can be built into a more complicated IC. So in my dream world, these are going to be the little battery/battery controller chips all in one that you can then just solder onto your PCB, and it's got kind of 10 or 20 milliamp hours of capacity. Maybe not enough to like run motors or heavy duty lights, but to run an IoT device and still be rechargeable, and all of this with something you can solder on a PCB. That's going to be really fun.
Right. So right at the beginning, you said that they don't exist yet, that's not the case. So they exist, but not at scale, and they don't exist in like the large capacities that we're necessarily looking for. Safety-wise, it seems like they get around 2 of the biggest problems with lithium batteries that we have right now. One of them is the dendrites, I think they call them, which are like whiskers that can form out into like the liquid electrolyte and eventually cause a short in the battery, and then your battery's toast. But the other thing is, my understanding is that the liquid electrolyte is the most flammable part of the battery. And so if you get rid of the liquid electrolyte, you don't have nearly the risk of catastrophic fire events that you do with cells right now. I find that really interesting. How do you replace that is the challenging part. And like you said, Murata has a lot of experience working with ceramics, which is important because this is going to be like an oxide ceramic barrier between the two. But the thing that has been kind of holding these back is that layer can then be brittle. And so you also have to figure out how to resist any kind of cracking that would give, a path, I guess, around the ceramic, like I guess through a crack rather than ionically through the ceramic. It's hard for me to figure out how to describe that part of it. But the hope is that they will, this technology will advance, and you'll have these batteries that are not only, easier to manufacture, easier to put into the product you're manufacturing because they can be pick and placed like a component, but then they can also operate at much higher currents, because you don't have the problem of that liquid electrolyte. And so if they do that, it means a faster charging. And I've seen numbers like 4 to 6 times the charging speed.
I just think that anything that's small like that and can contain a lot of power and be soldered to a PCB is going to be something that I'm going to get. And they're coming out in the fall. So if this was some small fly-by-night company, I might be a little more skeptical about it. But Murata is a huge manufacturer of ceramics in general and electronic ceramics in particular. So I'm kind of believing this. I'll make a project with them as soon as they show up in distributors.
I chose one of Maya Posh's articles this week, GitHub CoPilot and the Unfulfilled Promises of an Artificial Intelligence Future. I think from the title, you can kind of tell where Maya is going to land on this one.
Yeah, right.
But she did a good job of looking into this and kind of picking away the marketing hype and looking at what we're really looking at. So GitHub Copilot is something that was announced by GitHub as an invitation-only program, so it's difficult to get into it. But it ends up being a plugin for VS Code, which is a Microsoft product. GitHub was purchased by Microsoft, I don't know, in recent history, sometime in the last few years. And so it's not surprising to see that they're doing development there. In VS Code, you put this plugin in, and then you can type comments into the code that instruct the Copilot to do things. And those comments can be things like, sort this list from highest to lowest, and then it'll automatically give you like a hint that I think you can press tab or enter or something, and that hint will actually write itself into your code that has like a function declaration with the type of parameter that you asked for, and then it tries to put code in there that does what you asked for. The problem is, where is it getting that code? Like, it's not a prescient device that can tell what is in your mind, right? So it uses trained neural networks in order to try and figure out what you're asking for, like the most likely thing that you're asking for. And so Maya drills down into that and says what we expect it to be is this artificial general intelligence, like the holy grail that just knows what we're doing. But it's really artificial narrow intelligence that only knows the things that it was trained on. And in this case, I think it was trained on GitHub content, right, Elliot?
Yeah, imagine you're Microsoft and you own GitHub. You can train your neural network on GitHub, and that's pretty awesome. The problem is there's all of these details in coding that I don't know how specifically you can ask for in the comments. So like you say, takes input from the user, and it'll write something like makes a web form for you or something. Did you remember to say and sanitize it so that this person can't inject horrible scripts into my web backend? If you didn't put that in the comments, it's not going to do that for you. And so I've seen people on Twitter who are typing things in and getting code back from it that just, if you're at all security minded, just makes your skin crawl and makes alarm bells go off. Now, of course, is this better or worse than a horribly naive programmer attacking the same problem? I think it's actually just the same. So in that sense, it's kind of interesting. I think the idea is that you kind of want like a programming buddy, and this is like your AI pair programming friend. Except I think the problem here is that your friend doesn't really know what he's doing. And so it's like you're now paired with the juniorist programmer who's like, has an idea of how to get input from the user, but doesn't know why you need to sanitize it.
Right.
Or has seen a sorting routine, but doesn't know that in this particular case, you've got a sparse matrix of data and there's a most efficient way to sort that. And it's just like, bubble sort, right? That's the one everyone uses. I'll just use bubble sort. And so that's the kind of, I don't know what, nuances that people who program understand in the background that I think this won't yet. And I don't know how successfully you can put that sort of information into your comments. This may be, ironically, by giving you kind of the naivest possible assistant, forcing you to be more explicit and better in writing your comments that then give it the instructions to do its job. And so even though left to its own devices and given bad prompts, it might do stupid things, the kind of overall bigger effect may actually be to improve code quality. What do I know?
So one of the things that Maya did, because she didn't have access to the invite-only program, is she found 3 different people who had done testing, hands-on testing with this, and wrote very thoughtful reviews of their work on it. And I encourage you to go read those. I enjoyed reading through them, and I didn't think I would. Actually, when I got to it reading, I was like, oh, do these people know what they're talking about? But I ended up reading all 3 of those articles at length and enjoyed it. And one of the people is doing really in-depth things. So Simona Winekes is asking, it's multi-line comments that are addressing CoPilot that are giving it like multiple parameters for an input and asking for multiple different operations on it. And it's not good at it. Like, it fleshes it out. But I think, as you were just speaking to a moment ago, one of the biggest roles of being a programmer is knowing where the dragons are. And so if you have something that's writing this kind of advanced functionality for you, it's really easy just to not think about edge cases and skip over that. So it's like code creation, I think, is a scary thing with this. On the other hand, like code completion with this could be really great. So for instance, and I can't remember which one it was. It might have been Jeremy Howard was writing that, just did like / write text to file fname. And in the function that he was already in, text was a variable name and fname was a variable name. And so in Python, it popped out the with open as f, and it put the file name in there with the W and everything. This is something that I type often in Python and I can remember it some of the time, and so it's like these things that you when you see it, you'll know it's what you're looking for. Like that kind of code completion is really useful.
Yeah, and I think this is early days for this too, and I don't know if people are going to use it for kind of what he describes as, filling in the boilerplate on languages that are super boilerplate heavy like that, or whether it's going to be, more generally useful. If you read the FAQ over at CoPilot's webpage, when people wrote comments for it to flesh out, it came back with something that did what they asked for about half the time. So this is clearly something that's, in development still. If you define a unit test for it and it comes up with code that passes this unit test 50% of the time, we're not there yet, right? But will we be there? I don't know. That I can't rule out offhand. But if you're able to kind of give it these more fine-grained, low-level controls that then have it do the hard work for you, I think that could be super interesting.
I do want to talk just on one more point about Stack Overflow questions, because what we're talking about here is things that you would probably Google for or DuckDuckGo for and find a Stack Overflow question. And you can weigh this in a few different ways, like who's vetting the Stack Overflow question code? Who's vetting the GitHub code, right? So there's problems there in both ways. But when you get to Stack Overflow, there's usually a number of answers and there's usually a number of comments on those answers. And this is a place where you can learn about things, the unknowns that you weren't even on your radar can come up on how you're using these. And if you just take the answer and plug it into a page without reading the rest of the stuff that was on that overflow thread, I think you have missed out on an ability to, get better as a coder.
The funniest thing about Stack Overflow is there's always like the accepted answer, which is sometimes right. And then there's always the most popular answer, which is almost never right. And then there's always the actually complete and helpful answer, which is buried way the heck down there. And you need to scroll through like 5 pages of crazy stuff to get to the person who's finally like, look, what's wrong with this algorithm is this. Here's the right way to do it. And then they have some good links for you to follow. I agree with what you're saying. Navigating through Stack Overflow is a process of reading other people's comments and seeing which ones apply to your particular situation and which don't. Like, do you ever pick the first answer you get on Stack Overflow, or do you look for like 2 or 3 different questions that are very similar and then read through all of them to actually like do your research to figure out what the best way to handle the problem is?
Yeah, I think it's almost never the first question that I click on. This is the one that I'm looking for.
And so this is like some sort of like Russian roulette with Stack Overflow, except of course probability weighted Russian roulette because it's a neural network. Yeah, is that a good thing? That's a rhetorical question and the answer is no. But will it be a useful tool in the future? Can't say no.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking.
I was going to start and then you made noise. That's all the time we have for this episode of the Packaday?
Packaday.
The Packaday Hodcast. If you ask my son, he'll say upsy down.
So congratulations, Michael. We'll get a key-shirt.
Sennheiser? The Sennheiser.
Sennheiser.
Good old episode 130.